Hi, this is Mathematics in the Modern World. I'm Ma'am Shar, and today we kick off Chapter 1, Lesson 1, Mathematics in Nature. The following are the set of objectives. By the end of the lesson, the learner should be able to first identify the types of patterns in nature, and second, explain how these patterns reveal order in nature. Have you ever noticed the spiral of a snail shell, the branching of a tree, or the perfect symmetry of a flower and wondered, is this just coincidence?
Coincidence? I think not!
Mathematics is not just a paper or in textbooks. It's the hidden language that runs through everything around us. As Galileo Galilei famously said, the book of nature is written in the language of mathematics. So every spiral, every swirl, every pattern around us is a page in that book, waiting for us to understand it. Let's begin. When one shape is exactly like the other shape when it is moved, rotated, or flipped, we call this pattern in mathematics symmetry. Do you notice anything on the video today? It's mirage. Whatever on the left is reflected on the right side. If you put a line on the middle of my face, the result is almost the same because most faces are symmetrical. Unless, of course, the face you do on the last 5 minutes of your math exam. Yep.
What?
This line, which divides an object into two equal parts, is called line of symmetry or axis of symmetry. There are a lot of objects in the nature that follow the rules of symmetry. Can you think of a few? Wow, that butterfly is beautiful.
Wow.
If you draw an imaginary vertical line down the middle, we find that it divides the butterfly into two equal parts. Check this out. The butterfly visits a flower for nectar feeding. Closer look, the flower it is sitting on. Can we draw an imaginary line that divides the flower into two equal parts? Yes, we can. So the flower is also symmetrical. Look at the leaves of the plant. Are they also symmetric? Definitely yes. It is also symmetric. That's the beauty of nature. Next, fractals. A fractal is a complex geometric shape made using math that repeats the same pattern over and over, no matter how closely you zoom in. This quality is called self-similarity. Kapag sinabing self-similarity, ang ibig sabihin nito, each small part looks like a tiny version of the whole. The term fractal was introduced in 1975 by mathematician Benoit Mandelbrot. To describe these endlessly repeating patterns, he coined the word fractal based on Latin fractus, meaning broken. Once you know what to look for, fractals start to show up everywhere. Ferns are a classic example of fractals in nature. Each frond is made up of smaller leaflets that look like miniature versions of the whole. Romanesco broccoli, an edible example of fractal geometry in nature. The branching pattern of a lightning is a clear example of fractal geometry in motion. The fractal patterns in blood vessels helps deliver oxygen efficiently throughout the body. River systems show repeated branching patterns that help water flow efficiently across lands. Snowflakes grow outward in repeating six-sided patterns, tiny, natural fractals built by freezing water molecules. They say fractals are chaos, but they amaze me every time. As Benoit Mandelbrot said, a fractal is a way of saying infinity. Another common pattern in nature are spirals. These are curves that emanate from a point, moving progressively further away as they revolve around that point. Hurricanes are extreme weather events that can affect millions of people. That is how hurricanes appear from the air. Looking at a hurricane at this point of view, we can see a giant spiral shape. Consider water flowing down a drain. It forms a spiral. This is governed by the same mathematical principles seen in galaxies. The same is true for a spinning ice skater. And perhaps most unexpectedly, a flushing toilet. And there you have it. Just some of the most common patterns found in nature and everyday life. But there's so much more like chaos and tessellations.